Hi guys, welcome to my walkthrough of AQA's June 2018 GCSE Further Maths Paper 1, which is the non-calculator paper. So this is the last year in 2019 that you guys will be doing this spec. If you want any more papers to do, I also have walkthroughs of 2017 papers, and I've also done the spec papers for the new specification, which still all looks completely relevant to you guys. Also, Further Maths is basically AS level maths, so I have lots of content on that which I will link down below to help you guys with your further maths. So all the other papers can be found down below in the description. Let's go. Okay, question 1, we have differentiation. So I've got lots of stuff on this, check the description. So y is equal to x to the 6 over 2 and x to the 4 over 4. We want to work out dy by dx, simplifying our answer. So dy by dx means that we want to differentiate y. So when we differentiate x to the power of 6, the 6 comes down in front. The power of x decreases by 1, so we get 6x to the 5 over 2, and then add. So here the 4 comes down, so we get 4x, and the power goes down by 1, so we get 4x cubed over 4. So that's the differentiation done. Now we just need to simplify. So 6x to the 5 over 2 cancels to 3x to the 5, and 4x cubed over 4 is just x cubed. Cool. Okay, question 2, we have some coordinate geometry. So P is the point minus 12b. Q is the point A4. R is the point 6 minus 2. Q is the midpoint of PR. We want to work out the values of A and B. So, with this type of question, sketches are awesome. So it doesn't matter what our line is doing, we don't know the coordinates. We don't know all of the coordinates, so we don't know what the line is doing. So P is minus 12b, so let's put that down here. Then we know that Q is the midpoint of PR, so if we're putting R over here, then Q is somewhere here in the middle. Now the coordinates of R are 6 minus 2, and the coordinates of Q are A4. Right. So, midpoint coordinates are the mean of the two endpoints of the line. So, for Q, we know that if we add the x coordinates together of P and R and divide by 2, then we get A. So, minus 12, add 6, over 2 is equal to A. So, minus 12 add 6 is minus 6. Minus 6 divided by 2 gives us A is minus 3. Okay, now we need to find B. So, where's B? B is the y-coordinate of P. So, we know that B add the y-coordinate of R, so add minus 2, so B minus 2 over 2 is equal to the y-coordinate of Q, which is 4. Now if we multiply through by 2, we get B minus 2 is equal to 8. So B is equal to 10. Cool. Okay, question 3, we have multiplication of matrices. So, A is 2, 4, 3, minus 1, and B is minus 2, 6, 2, and 1. We want to work out A, B. So, let's write this out. So we got 2, 4, 3, minus 1 times minus 2, 6, 2, 1. Okay, so what happens with matrix multiplication is the first column of the second matrix multiplies the first row of the first matrix. So that gives us our top left element in our answer. So we're going to get minus 2 times 2 and then add 2 times 4. Okay, let's change colour. Okay, now for the top right element, we do the second column of the second matrix times the first row of the first matrix. So, for that, we're going to get 6 times 2 and then add 1 times 4. So what I'm going to do as well is make our little answer matrix down here. AB is equal to, so at the moment we know the top left element, it's minus 2 times 2 is minus 4, add 2 times 4 is add 8, so our top left element is minus 4 plus 8, which is 4, and our top right element, 6 times 2 add 1 times 4 is 12 add 4, which is 16. Okay, now our bottom left element is the first column, the second matrix, times the second row of the first matrix. So, that's going to give us minus 2 times 3 add 2 times minus 1. Now that's going to give us minus 6 minus 2. So that's going to give us minus 8. And then the final element is the second column multiplied by the second row. So we're going to get 6 times 3 and then add 1 times minus 1. So that's going to give us 6 times 3 is 18. 1 times minus 1 is minus 1. So that is going to give us 17. So that is our matrix AB. In question 4, we have some tasty algebra. So P is 4x, Q is 7x. P increases by 25%. Q decreases by 40%. Now P is 28 greater than Q. We want to work out the value of x. Okay, so 25% of 4x is a quarter of 4x. So that's going to be just 1x. So when P increases by 25%, P is now 5x. Q decreases by 40%, so not quite as nice. So 10% of 7x is 0.7x. So 40% is 2.8x. So Q Q is now 7x minus 2.8x, which gives us 4.2x. Okay, so now we're told P is 28 greater than Q. So that means P is equal to Q add 28. So 5x is equal to 4.2x add 28. So take away the 4.2x, we get 0.8x is equal to 28. Now we got 0.8x and we don't have a calculator to help us. So let's turn 0.8x into 8x by multiplying by 10. So we get 8x is 280 and then divide by 8. So x is 280 over 8. Now that has a common factor at least of 2. So it's 140 over 4, which is 70 over 2, which is 35. Cool. Okay, next up, in the expansion and simplification of x minus 3 times x squared add 5x add k, the coefficient of x squared is equal to the coefficient of x. K is a constant. Find the value of k. Okay, so we don't need to expand this whole thing. All that we need, although we could, let's do it. It's good practice. So, I'm going to use a table. Tables are good. So the reason I would recommend using a table is because we got a quadratic which has 3 terms. So we're going to put x and minus 3 down the side, x squared, 5x and k across the top. Now each box is a multiplication between what's at the side and what's at the top. So x times x squared is x cubed, minus 3 times x squared is exactly that. X times 5x is 5x squared, minus 3 times 5x is minus 15x, x times k is kx, and minus 3 times k is minus 3k. Now, we don't need to take all of that out of the table. We are only interested in the x squareds and the x's. So, the reason for that is because we are told the coefficient of x squared is equal to the coefficient of x. So, we know then that we have 5x squared minus 3x squared, and that is 2x squared. So the coefficient of x squared and x, because we are told they are equal, is 2. Now what's going to happen at the moment, our coefficient of x is going to have a k involved. So we know that kx minus 15x has to be 2x. Now if we divide through by x, k minus 15 is equal to 2, add 15, k is equal to 17. Okay, in question 6 we have equations of circles. So I got lots on this in my coordinate geometry playlist down below. So a circle has centre minus 1, 2 and radius 5. We want to tick a box for the equation of the circle. So a B with radius R has equation x minus a squared add y minus b squared is equal to the radius squared. So here we know the radius is 5, so we know on the right we're going to have 25. Now our x coordinate of the centre is minus 1. So the signs inside the brackets and coordinates are opposite. So if our x coordinate is minus 1, we're going to have x plus 1 squared, and then the y coordinate is 2, so we're going to have y minus 2 squared. So that's the guy we're looking for. So there he is. It's the third one. Cool. Okay, question 7. We have some circle theorems fun. I've got lots on these. Check down below. So, points A, B and C are on a circle, centre O. Angle AOC is x at 75 degrees, and angle ABC is 2x. So there's our situation. Now, our mission is to work out the value of x. So, not completely obvious what to do here. What we need to remember is we have a circle with an arrowhead type job going on, and then the angle at the centre is double the angle at the outside. So if that's x, then we got 2x down here. So what we can do, because O is the centre, we can draw lines like this and create ourselves this little arrowhead. So now what we know is that this angle up here is x at 75 all over 2. So it's half of that angle at the centre. How is this useful? Well, now we got another theorem going on as well. We now have a cyclic quadrilateral. Now, opposite angles in cyclic quadrilaterals add up to 180 degrees. So we know that x at 75 over 2 add the opposite angle, so this guy down here, 2x is equal to 180. So now we need to solve this for x. So let's start by multiplying through by 2. So we get x add 75 add 4x is equal to 360. So we got 5x add 75 is 360. Take 75. 5x is a number 285. So x is 285 divided by 5. Which we can use the bus stop for. So 5's into 2, nope. Carry the 2. 5's into 28, goes 5 times. Remainder 3. 5's into 35, go 7 times. So x is 57 degrees. Okay, question 8, we have surds. I have plenty of stuff on surds. Check down below. So we want to write 1 add 2 root 5 times 4 minus root 5 in the form a and b root 5, where a and b are integers, whole numbers. Okay, so basically expand these brackets. So let's use a table. So let's put 1 and 2 root 5 down the side, and then 4 minus root 5 across the top. Okay, so 1 times 4 is 4. 1 times minus root 5 is minus root 5. 4 times 2 root 5 is 8 root 5. And now we got the tricky one. So we got 2 root 5 times minus root 5. Now that is going to give us minus 2 root 5 root 5. Root 5 root 5 is 5. So we got minus 2 times 5, which is minus 10. So we get 4 minus 10, add 8 root 5, minus 1 root 5. 4 minus 10 is minus 6. And then we've got add 7 root 5. Cool. Okay, question 9, we have functions. Again, plenty of stuff on this. Check down below. So, f of x is 14 minus x squared for all values of x. We want to solve f of 2x equals 5. We must show our working, and it's a nice 4-mark question, so I believe this is the biggest one so far. So, f of 2x means that wherever there is an x in f of x, it becomes 2x. And whatever was happening to x is now happening to 2x. So, f of 2x is 14 minus 2x squared. Now this is 14 minus 4x squared. So, f of 2x equals 5 is the same as 14 minus 4x squared is equal to 5. Now, if we add the 4x squared to both sides, 14 is 4x squared, add 5, take away the 5, we get 9 is equal to 4x squared. Divide by 4, 9 over 4 is equal to x squared. Now, we square root both sides, and we need to be extremely careful here. When you square root, technically you get two answers, positive and negative. So, we get from this that x is plus or minus the square root of 9 over 4. Now this is plus or minus 3 over 2. Go. Okay, question 10. We want to rearrange 1 over xy equals 4 minus 3y to make x the subject. So, we need to be really careful here. So, first of all, let's multiply through by y. So that's going to cancel out the y on the bottom on the left. It's going to give us 4y in the middle, and then it's going to cancel out that y under the 3. Now if we multiply through by x, we get 1 is equal to 4x y minus 3x. Now we want to make x the subject, so we need x to only appear once throughout this whole thing. At the moment it appears twice, and 1 is an algebraic term, 1 is a numeric term. So to turn these two terms on the right into one term, we factorise. So we get x lots of 4y minus 3. So then to get x on its own, we divide both sides by that bracket, and that's not a 7, that's a 1. So we get 1 over 4y minus 3 is equal to x. If you want more questions like that, check out my rearranging algebraic fractions video down below. Question 11, a nice full marker here. So a curve has equation y equals 2x squared add 3x minus 9. At point P on the curve, the tangent is parallel to the line y equals 4 minus 5x. We want to work out the coordinates of P. So, the gradient of y equals 4 minus 5x is minus 5. So that tells us the gradient of the curve at P is minus 5. Because the tangent is a line that touches a curve at a single point. So at that point, the tangent and the curve have the same gradient. Now, how do we find the gradient of a curve? We differentiate. So dy by dx is going to be, well, 2x squared differentiates to 4x. And then 3x differentiates to 3 and minus 9 disappears. So we get 4x add 3. Now we know at P, remember the derivative is the gradient function of a curve. So to find the gradient at a certain point, you would substitute in the x-coordinate to the derivative. Or, if we know the gradient, as we do here, we can do a bit of backwards engineering and find the x-coordinate. So at P we know that 4x add 3 is equal to minus 5. So if we take away the 3, 4x is minus 8. So x is minus 2. So we know our x-coordinate. How then do we find our y-coordinate? Well, we then substitute our x-coordinate into the equation of the curve. Remember, equations are like recipes. They tell you how to make y when you know what x is. So, when x is minus 2, y is 2 lots of minus 2 squared, add 3 times minus 2, minus 9. Now minus 2 squared is 4, 2 times 4 is 8. 3 lots of minus 2 is minus 6. So we got 8 minus 6 minus 9. 8 minus 6 is 2. 2 minus 9 gives us minus 7. So our y-coordinate is minus 7. Cool. Okay, question 12, quite a big one. So, in the diagram, A is the point 15, 0, and B lies on the y-axis. Angle ABC is 90 degrees, so that's our right angle there, and tan of theta, theta being down there, is 5/3. We want to work out the equation of the line BC. So the line that we want is this guy here. So, quite a lot to do. What we do know is that AB and BC are perpendicular. Now, when lines are perpendicular, their gradients multiply together to give us -1. Now, the problem with that is we can't find any gradients yet. What we need to do is find out the coordinates of B. So, we are told that tan of theta is equal to 5/3. Now remember, from SOHCAHTOA, tan is the TOA part. So tan of theta is equal to the opposite over the adjacent. Now that allows us then to, if we can call this the opposite, and we can call this the adjacent, and then we know that tan of theta is equal to the opposite over, now we know this length because the x-coordinate is 15, so over 15, let's call that up so it doesn't look like 0. So we know then that this opposite divided by 15 simplifies to 5/3. So to get back from 3 to 15, we multiply by 5. So to get our value for the opposite, we times 5 by 5. So that tells us then that this height over here is 25. So now all of a sudden we know the coordinates at point B are 0, 25. Now what this allows us to do is the rest of the question, which is good. So we can now find the gradient of AB. So the gradient, let's call it MAB. Now remember, gradient is difference in y over difference in x. So I'm going to do the coordinates at A minus the coordinates at B. So I'm going to get 0 minus 25 over 15 minus 0. Now that's going to give us minus 25 over 15, which is minus 5/3. Now, from that, because these lines are perpendicular again, their gradients multiply together to -1. So we know then that minus 5/3 times the gradient of BC c is equal to minus 1. So if we multiply through by 3, we get minus 5 times the gradient of BC is equal to minus 3. And then if we divide through by minus 5, we get the gradient of BC is 3/5. So, now that we know the gradient, we can now start to work out the equation. General equation of a straight line is y equals mx plus c. So we now know then that BC is of the form y equals 3/5 x add c. Now to find c, we substitute in the coordinates of a point that we know lies on the line. So here we know the coordinates at point B are 0, 25. So when x is 0, y is 25. So if we substitute those in, we get 25 is equal to 3/5 times 0 is 0. So 25 is c. So the equation of our line is y equals 3/5 x add 25. Cool. Okay, question 13. For 6 marks, wants us to solve the simultaneous equations xy is equal to 2 and y is equal to 3x add 5. Do not use trial and improvement. You must show your workings. So, for 6 marks, I would say this is quite nice. I would say it's probably more straightforward than that equation of a line question just now. So, we know that x times y is 2. Now we know that y is equal to 3x add 5. So the game with simultaneous equations is always to try and get an equation in terms of just one variable, so one letter. Now, we can do that because we know what y is in terms of x. So we're going to substitute y equals 3x add 5 into xy equals 2. So we know that x or y, but y is 3x add 5 is equal to 2. Now if we expand the brackets, we get 3x squared add 5x is equal to 2. Take away the 2 and we get 3x squared add 5x. Sorry, the reason that we're taking away the 2 is that because we have an x squared term, this is a quadratic. To solve a quadratic, we need everything on the same side with a 0 on the other. So if we take away that 2, minus 2 is equal to 0. Now because this is a non-calculated paper, we're not going to need the quadratic formula or anything horrible like that. Hopefully we can get nice numbers. So let's try factorising. So because we have a 3x squared, we're going to need a 3x and then an x in the other bracket. Now the two numbers need to multiply to minus 2 and we need to end up with 5x. So if we put a plus 2 in there, and 2 times 3x gives us 6x. If we put a minus 1 in there, that's going to give us minus x, which takes us down to 5x in the middle as we need. So when you're solving quadratics and you're factorising, you set whatever is inside each bracket equal to 0 and solve for x. So this first bracket tells us 3x minus 1 is equal to 0, 3x is equal to 1, x is equal to 1/3, or this other bracket tells us x plus 2 is equal to 0, so x is equal to minus 2. Now, those are our two x values. We need to find the corresponding y value for each of these. So, when x is 1/3, y is going to be, well, remember that we know y is 3x add 5. So y is 3 times 1/3 add 5. Now 3 times 1/3 is just 1. So y is equal to 6. So one of our solutions, one of our set of coordinates are x equals 1/3, y equals 6, which in coordinate form we could write as 1/3, 6, and then we know the other x value is minus 2. So when x is equal to minus 2, or y is equal to 3 times minus 2, add 5. So 3 times minus 2 is minus 6, add 5 is minus 1. So our other pair of solutions are x equals minus 2, y equals minus 1, which in coordinate form is minus 2 minus 1. Go. Question 14 wants us to work out the value of 3 to the 1/2 and 3 to the 3/2 all squared. So this is double bracket expansion. So this means 3 to the 1/2 add 3 to the 3/2 times 3 to the 1/2 add 3 to the 3/2. So choose a table. So we're going to have 3 to the 1/2 there, 3 to the 3/2 there, 3 to the 1/2, 3 to the 3/2. So remember, by the rules of indices, when you're multiplying multiplying the same base number together, you add the indices. So 3 to the 1/2 times 3 to the 1/2 is 3 to the 1, which is 3. 3 to the 1/2 times 3 to the 3/2 is 3 to the 4/2. 3 to the 4/2 is 3 to the 2, which is 9. So then we get exactly the same down here, and then bottom right, 3 to the 3/2 times 3 to the 3/2 is 3 to the 6/2. 6/2 is 3, so we got 3 cubed, which is 27. So we've got 27, add 9, add 9, add 3. Now that is going to give us 48. Jump in. Okay, question 15. We have the graph of y equals 3x minus x squared for values of x from -1 to 4. So, there's our graph, times. Now the question says, by drawing a suitable linear graph on the grid, work out approximate solutions to x squared minus 4x add 2 is equal to 0. So, given that on the previous page we have the graph of y equals 3x minus x squared, we want to manipulate this equation so that we have 3x minus x squared on one side. So the reason for doing this is that we're thinking simultaneous equations here and graphically, so solutions to simultaneous equations are at the point or points where lines and curves meet. So, first of all, here we have a positive x squared. Now here we have a negative x squared. So first up, let's subtract x squared from both sides. So we get minus 4x add 2 is equal to minus x squared. Now, this guy also has a 3x on the same side as the minus x squared. So, what we're going to do here is now add 3x to both sides. So we get minus x add 2 is equal to 3x minus x squared. So what we got now, this is the quadratic that is already sketched for us, and minus x add 2 is the straight line, so it's the linear graph that we want to plot. So we want to plot y equals minus x add 2. So, to do that, let's use a little coordinate table to get some points. So let's use 0, 1 and 2. So when x is 0, y is 2. When x is 1, y is minus 1 and 2, which is 1. And then when x is 2, y is minus 2 and 2, which is 0. So if we plot those points, so we had, forgotten already, 0, 2, so 0, 2 is here, and we had 1, 1, so 1, 1 is there, and then third point was 2, 0. Now the reason for using 3 points instead of 2 is if you only use 2, you can't tell if you've cocked up. If you use 3 and they're all on a straight line, then you're golden. So what I need to do now is join those up with a straight line. Okay, so there's how our straight line should look. Now the x values that we want are the ones where the line intersects the curve. So we got this point here, which if we go down to the x-axis, it looks to be about, well, I'd say it's 1 square to the right of the thick line. So there are 10 little squares between 0 and 1. So that's going to be 0.6. So that's one value. And the other is over here. So I guess we would say it's gonna be that. So I would say it's gonna be there. So that is 3.4. Cool. Okay, 16, we have curve sketching. So y equals f of x is a cubic curve with a maximum and a minimum stationary point. We are told that dy by dx is x squared add 2x minus 3. The y coordinate of the minimum point is 2 and a third. The y coordinate of the maximum point is 13. 0, 4 is a point on the curve, so that's where x is equal to 0, so that's going to be our y-intercept. The tangent at 0, 4 has a negative gradient, so that tells us when the curve goes through the y-axis, it has a negative gradient. We want to sketch the curve on the grid below. Show the coordinates of the stationary points. So, at the moment, we can put the point 0, 4 on, and we know the graph is going down through like that, because it has a negative gradient. Okay, now, at stationary points, the gradient is equal to 0. So that means dy by dx is equal to 0. So what we can do is find the x coordinates of the stationary points using dy by dx. So we know then that x squared add 2x minus 3 is equal to 0. So it's quadratic, we need to factorise. So this factorises to x in each bracket. Then we need a minus 3 at the end with a plus 2x in the middle. So we're going to have x plus 3 times x minus 1. So the x coordinates of the stationary points are x equals minus 3 and x equals 1. Now, because the curve is going through the y-axis with a a negative gradient, well, that then means that the maximum has to be on the left of the y-axis. So this is doing something like that. Now we know the x-coordinate of the maximum is going to be the negative that we just found, so it's going to be -3. Now the question also told us what the y-coordinate was. So the y-coordinate of the maximum is 13. So the maximum is at -3, 13, and then the minimum, well, we know that the y-coordinate of the minimum is 2 1/3. So that tells us then the graph does not go through the x-axis again, because the minimum is positive. So our graph is going to look something like this. Now we know that our x-coordinate is 1, and our y-coordinate, forgotten again, is 2 1/3. So there is a sketch of our cubic. Cool. Okay, question 17, we have the factor theorem. So I've got plenty of stuff on this in my polynomials playlist down below. So we want to use the factor theorem to show that x minus 2 is a factor of x cubed add 8x squared add 5x minus 50. So, by the factor theorem, if x minus 2 is a factor, then f of 2 will equal 0. So, we get 2 cubed is 8, so f of 2 is 8, and then we got add 8x squared, 2 squared is 4, 8 times 4 is 32, and then we got add 5 times 2, which on a good day is 10. Now all of that is 50, then we got minus 50, so that does indeed equal 0. So x minus 2 is a factor. Okay, and then Barbie says, hence factorise fully x cubed add 8x squared add 5x minus 50. So again, let's think of it as f of x. Sure, because it's a cubic, we know that either it has 3 linear factors, one of which we know, times either a quadratic factor or 2 more linear factors. So either it has 3 linear factors or a linear and a quadratic. So let's assume it's going to be 3 linear. So let's just try playing around with the factor theorem. Now we know that the numbers going inside of the brackets need to multiply together to minus 50. So let's try 5. Let's see what happens with that. So f of 5 is going to be 5 cubed, which is 125, add 8 times 5 squared, so 5 squared is 25, 8 times that is 200, so you can see already, don't think this is going to work. Add 5 times 5, so add 25 minus 50, so there's no way that is equal to 0. So x minus 5 is not a factor. Let's try f of minus 5. So minus 5 cubed is minus 125. Minus 5 squared is 25. 8 times that again gives us plus 200. And then add 5 times 5. It's going to give us minus 25. And then we got the minus 50 on the end. So, minus 125 minus 25 is minus 150 minus the other 50, and we get minus 200. So 200 minus 200 does indeed equal 0. Therefore, x plus 5 is a factor. So, up to here then, we now know that f of x is x minus 2 times x plus 5. Now at the moment, we know that minus 2 times 5 is minus 10. So to get the third factor, we can use the fact that the minus 10 needs to multiply by a number to give us minus 50. So minus 10 times positive 5 is going to give us minus 50. So the third factor is also x add 5. So there he is, fully factorised. In question 18, we have a tricky geometrical proof. So, D, E, F and S are points on a circle. RST is a tangent, so RST is this bottom right line here, and that's a tangent. The straight line EDT is parallel to FS, so EDT is this top line, this guy, and that is parallel to FS, so FS is that guy there, so those two lines are parallel. So we're told that ds is equal to dt, so that's those two lines here with dashes on them. Okay, now what we want to do is prove that FD is parallel to RST. So again, RST is the tangent and FD is this line here. So we are told to use angle DTS as x to help us. So they've already put that on for us. So I've not done this yet, so I don't know where we're going. Let's see what we can figure out. Okay, first of all then, this triangle with these two equal sides is then isosceles. So we know that this angle here is also angle x. Now that means we can also say what this angle here is. Angles in a triangle add up to 180. So this angle here is the difference between 180 and those two angles of x. So it's 180 minus 2x. We might need that, we might not, I don't know. Questions like this are all about filling in just any blanks that we can and hope that they help us. Okay, next up. So, this line hitting the circle, RST, is a tangent. Now, sitting on that tangent, we have a triangle. So this triangle here. Now, when you have the point of a triangle inside a circle sat on a tangent, we can use the alternate segment theorem. So the alternate segment theorem tells us then that if this angle is x, then this angle here is also x. So my circle theorem stuff is down below in the description if you want to have a look. What can we do from there then? Well, that is a very good question. Let's see. Right, we know that these two lines here are parallel. So what we have going on here is a cheeky little z. So now we can be thinking in terms of alternate angles. So if we know this angle here is x, we also know that this angle here is x. So where does that put us up to here? Well, okay, so the next thing that I can see that might help us is that we can work out this angle in here. So for now, let's call that a y. Now we know we got three angles here now that lie on a straight line. So now we know that x add y add 180 minus 2x is equal to 180. Because angles on a straight line do that. So if we simplify that, we got x minus 2x, so that's minus x, add y. Now we can take away 180 from both sides, so we get minus x and y is equal to 0, therefore y is equal to x. So this guy here then is x. Now inside of this triangle down here, we now know two of the three angles. So this triangle here. So we got two angles of x. So we can work out what this angle here is. Again, it's going to be 180 minus 2x. Now we got one of those earlier, which is up here. Now remember, what we're trying to prove is that FD is parallel to RST. So, oh hello, we've done it. So we didn't need that last 180 minus 2x. So, how we've done it is we've got this little z going on here, and we've got these two alternate angles, or what would be alternate angles if the lines were parallel, and they are both the same. They are x. So we would finish off by saying that angle FTS and angle DST sit inside a Z and are equal, so are therefore alternate angles and so FD is parallel to RTS. Go. Okay, question 19 wants us to write 2x squared minus 16x add 13 in the form a times x add b squared add c, where a, b and c are integers, so whole numbers. So this is completing the square, and it's trickier completing the square because we have a coefficient on the x squared term. So I've got loads of videos on this, they'll be in the description down below. So the first thing to do here is to factorise out the coefficient on the x squared. Some teachers would tell you just to divide the first two terms by 2. Why? I don't know, that complicates things. Let's take 2 out of every term. So it factorises to 2 times 1x squared minus 8x add 13 over 2. Now the reason for doing that is inside the square brackets we now have a quadratic with a single x squared. So we can complete the square, so we get x minus 4 squared. Now whatever that number inside the bracket is, positive or negative, you always square it and always subtract it on the outside. So we get minus 16 add 13 over 2. Now, this is 2 lots. X minus 4 squared. Now, 16 in terms of halves is 32 halves. So we've got 32 halves, minus 32 halves, add 13 halves. So that is going to give us, well, minus 32 add 13 is minus 19. So we got minus 19 halves. Now finally, we can let that 2 back inside the square brackets. It can't get inside the round brackets. The power of 2 acts as a little bouncer, saying, no mate, you're not coming in. So all it can do there is sit on the outside, like that. But it is going to multiply the minus 19 over 2. That's just going to give us minus 19. Cool. Okay, question 20. Final question. So we got a non-right angle triangle with trigonometry. Now what we are going to need here is our exact trig values. So pretty soon, probably by the time you're watching this, I will have made a video explaining how to work those out. So it's trigonometry without a calculator. Okay, so trigonometry. In triangle ABC, AB is 6 root 2 centimeters. Angle ABC is 45 degrees, and angle ACB is 60 degrees. Now we got this side length over here of x, and as always our mission is to work out the value of x in the form a root b, where a and b are integers. Okay, so we're in a non-right angled triangle. We have a matching pair of known side and known angle, and we know another angle, so we can use the sine rule. So the sine rule, remember, tells us a over sine a is equal to b over sine b is equal to c over sine c. That's the ideal form to use when we are looking for side lengths, which we are. So using that, we can say that x over sine of 45 is equal to 6 root 2 over sine of 60. Now, the two trig values then that we need to know are sine of 45 is root 2 over 2, and sine of 60 is root 3 over 2. So, I'll put a link to my video down below. So, x over sine of 45 becomes x over root 2 over 2, and that is equal to 6 root 2 over root 3 over 2. Okay, so essentially on both sides we are dividing by a fraction. Now if you divide by a fraction, you flip it and times by it. So we got x times 2 over root 2 is equal to 6 root 2 times 2 over root 3. So, on the left, we can write that as 2x over root 2 is equal to, on the right, 6 root 2 times 2 is 12 root 2 over root 3. Okay, so from this, we want to get x on its own. So if we multiply 3 by 2, we get 2x is 12. Now, it's times root 2 times root 2 over root 3. Now, root 2 times root 2 is 2. So we got 2x is equal to 12 times 2, which is 24, over root 3. If we divide by 2, we get x is 12 over root 3. Now all we need to do is rationalise the denominator. So this is 12 root 3 over 3, which finally gives us x is equal to 4 root 3. Cool. Okay guys, that's the paper done. Hopefully paper 2 is linked down below in the description. Hope you found this useful. Take it easy. Take care.